Thank you all for coming today. My name is Vijay Tolani. We're going to talk today about how you can get started with big data in the cloud. So we'll start out talking about kind of a high level defining what big data is, and then we'll go through just kind of some of the things that I've seen talking with a number of different customers and prospects about the various projects that they're working on in the cloud. So big data is one of those things that it's one of those hot, trendy buzzwords out there that everyone throws out, kind of like cloud computing. And so I think it's really important to take a step back and first of all define the problem, and then take a look at it and say, all right, how are we what are we defining as big data, and realizing some of the historical models and how that plays in, and then focusing on some specific technical solutions and really trying to give you the knowledge you need to really get yourself kick-started and kick off those projects. So before we do that, I'll take a quick poll of the audience. Who here has experience with infrastructure as a service cloud computing and or RightScale? All right, so most of us. How about Hadoop? Who has experience with Hadoop? So a few folks. What about NoSQL? All right, so it sounds like we've got a decent audience here and you guys have some experience with it. So we'll go through this stuff relatively quickly. So we'll go through, we'll start out, we'll define big data, we'll define that problem, and then we'll go through some of those solutions, and we'll focus specifically on a couple of key areas. The first being NoSQL and the second being Hadoop itself, and we'll talk about some of the solutions that RightScale and the RightScale ecosystem can provide within that framework. So if we start out by defining what big data is, I really like the O'Reilly definition, which effectively says, hey, big data is trying to work with and analyze any data set that is just larger, more complex, structured differently than our conventional database technologies could handle. Right? I think that kind of sums it up relatively well. This data is coming at us faster, it's coming at us in different formats, and it's coming at us in a higher volume than we've seen in the past, and it's causing us to rethink some of the ways we assess those types of challenges. So now that we've defined what big data is, we can take a look and start to say, what sort of questions can we answer with this? And we've got an audience here that's relatively familiar with some of the concepts here. And let's say, all right, why is the cloud a good fit for big data? Why would we want to do this on the cloud and not necessarily go out and build our own clusters? A lot of people have been doing this for a long time. And if you ask yourself, okay, what types of questions and what types of insight could I gain if I had access to a 100-node Hadoop cluster? You could do a whole heck of a lot of stuff with that. But then you start trying to operationalize that. Right? At RightScale, we're all about how we can take these projects and make them real and actually get them done. And you say, all right, I got to go out and I got to buy 100 physical servers to make this thing happen. How do I get that funded within my organization? How do I make that work? And that's really what makes the cloud such a good fit for this, is due to the batch processing nature of Hadoop. And you start looking at that and you say, all right, normally you'd go and say, all right, I need to run this job, but I only have access to 4 or 5 servers. Hey, it's going to take hundreds of hours to complete. But when I start working on the cloud, because I have the ability to parallelize these processes, and I'm renting servers by the hour, well, I can have a 100-node cluster, or a 1,000-node cluster, or a 2,000-node cluster, and get my job done in an hour, right? And it's no more expensive to have a 10-node cluster and run it for 10 hours, or have a 100-node cluster and run it for 1 hour. So it's really a very nice fit from that perspective. Now, if we back all the way up, and we start looking at historically how we've built databases, right? Databases have been around forever, and historically you look at databases, and when someone says database, you think it's a relational database. Of course it is. And you say, how do I query that database? Well, I use SQL to query that database. It was almost synonymous. But when you start looking at it, and we'll dive a little bit deeper into the problem itself, these types of structures can be challenging. By storing all of our data in tables, and the tables are related via relations, and accessing it via SQL can become pretty challenging when you start looking at some of the real-world data that's coming our way right now. So I'm going to start out by telling you a story. You guys have probably seen this app. It's an app called Draw Something. It's one of those games that just, for whatever reason, is unbelievably addictive. You go, you've got the challenge of, you've got a word, you've got to draw it, send it to your friend, and they've got to figure out what you just drew. Unbelievably challenging, but entertaining at the same time. And now you go and you start looking at how these applications take off. And these are the types of things that you've seen from RightScale over and over. And here specifically, they had some nice plugs of being out on Jersey Shore and people tweeting their message. One way or another, they've scaled at an unbelievable tick. Now, the specific challenge here with Draw Something is they've got to go and take all of those image files and store all of them. And you think of how you would handle that with a relational database, and it could be extremely challenging. So here we look specifically and look at how quickly they scaled up. This is looking at a month's period. And they scaled up to 30 million downloads and ultimately gets up to 3.3 terabytes of data in a 1-month period. And this is one example of the amount of data that's coming our way. So you specifically start looking at challenges that we see with social media. And I use social media as an example just because I think it relates to everyone very, very well. And you look at the amount of data that's out if you want to take a Facebook feed or a Twitter feed and start doing something with that data and coming to some conclusion from that information. You start looking at Facebook and you say, all right, there's 40 billion photos and 10 terabytes of data coming from logs from Facebook on a daily basis. You want to bring in a Twitter feed. You're talking about 7 terabytes of data per day. Let's say you wanted to go and perform some financial analytics. You want to take a look at all of this data coming out of the New York Stock Exchange based on transactions for a day. You're talking about a terabyte of trade information. So ultimately, the classic definition for big data here starts with the 3 key criteria of volume, velocity, and variety. And what that's saying is, first of all, the amount of data coming at us is absolutely massive. That's the volume aspect of it. The second aspect of it is the variety of it. Now that you're going and you're trying to analyze, Facebook wall posts or emails or text messages, this isn't data that is structured in a way that would normally fit in a relational database. So you're talking about taking not only structured data, but semi-structured and unstructured data as well. And the third piece is, this isn't just large data sets, but it's coming at us unbelievably fast. So it's the velocity that that data is coming at us. When you start looking at this criteria, it becomes very, very obvious that there's a need for another solution to handle these new, unique set of challenges that we're now faced with on a daily basis. What I found that was really, really interesting is when we first started getting into this space, it's, okay, big data. Well, what's big data? And you immediately jump to Hadoop and that analytics that you can do. And you say, all right, I've got all of this information coming from Facebook. How do I analyze it? What can I do with it? And what I found when I started talking to more and more customers and prospects is they had a more foundational problem in that it wasn't even the analytics. It was the fact that they had this big data warehousing solution and they didn't have the capacity to store all of that information. Hadoop, by its nature, is not a streaming analytics platform. It's a batch processing platform. You can take all of this data and load it into HDFS and then perform some operation on it. But if you didn't have the capacity to store the data to begin with, well, then you were dead in the water right there. So what I've seen more and more people start to do is, before they go through that process of building out a Hadoop cluster, they start looking at newer and more scalable technologies for storing the data itself. And specifically, we've seen a lot of success with NoSQL. And you're starting to see the integration between NoSQL and Hadoop to really make a very, very powerful solution together. And that's what we're going to talk about today. So before we do that, we'll take a quick high level and talk about what NoSQL itself is. So NoSQL, first of all, is not a replacement for a relational database, right? A lot of people look at NoSQL and it's kind of a cheeky term that's thrown out there. I like the definition of NoSQL as calling it not only SQL, right? We're saying that SQL is not the only database solution out there. And we'll talk about the various different types of NoSQL databases that exist. But the short of it is these are databases that were designed to run on commodity hardware. They were designed to scale out. But it's not a magical solution to all things, right? You look at a relational database and we're used to having those classic ACID properties for any transaction. And you look at a NoSQL database and you don't have that. You aren't necessarily guaranteed that immediate consistency of your data. But if you're now going and you're trying to store this massive amount of information, you have to ask yourself, maybe immediate consistency isn't the most important requirement. Maybe scalability is a more important requirement, or hyper performance is a more important requirement. And that's where NoSQL starts to become more appealing. But at the same time, you start looking at it, and we defined a database as something that was accessed via SQL, effectively. And now we have to learn a new way of interacting with that database. And that we're not using SQL directly, but a whole host of different languages and scripting technologies. And we'll talk a little bit about some of those today. But the short of it is, if you have a relatively simple data set, you're not looking for this massive relational capability of associating all of this data. And really, flexibility is more important than anything else. And high performance is more important than necessarily that rigid structure and that relational capability. NoSQL may be a very good solution for you. So when we look at NoSQL databases, there's a number of different varieties of doing that. And the simplest type is a simple key value store. So I've got some index that I'm looking up, I have that key, and there's some value associated with it. And we'll talk about some various types of these databases and some good applications for these databases. The second is a document database, which is effectively a key value store, but instead of just a plain text value or a numerical value, we now have a more complex structure in that value. Now we have an XML or a JSON file there. So there's more advanced capability in terms of what I could actually store there. And the third is the most advanced database, and that's the column-oriented database. Now this one took a little bit of understanding when I first looked at it, because you look at a column-oriented database and you start saying, hey, isn't that just like a relational database? It's a bunch of rows and columns. I mean, isn't that a table? And I think the best way to understand that is if you think of a relational database as like an Excel spreadsheet. You go and you have a fixed number of rows and a fixed number of columns. And if you don't have data inside of any of those cells, well, it's just wasted space. A NoSQL column-oriented database is a little bit different because it's still a key, being that row, and a number of associated values. But at no point would you ever have a null value in between there. So it's really more of a list of associated values with this particular column or this particular row, but you would never have that wasted space of having null values in between there, and it's much more flexible in terms of what you may be able to do. So here, if we look at the first value in row A and the first value in row B, there's no reason that those need to be of the same type. Whereas in a relational database, you have that very rigid schema in terms of how this data is defined. This shifting gears a little bit, if we start looking more at how we can do some data analytics and perform some level of parallel processing, it's important to understand the foundational components of MapReduce. Because before you really get into any serious analytics, this is a key construct to understand. So the example that's used most often is that of a word count function. So here we're doing this very, very simple. And let's say that we're going and we're just reading letters out of a book. Here we've got the letter A, 2 B's, a C, and a D. And what we're ultimately trying to come up with is how many A's, how many B's, how many C's, and how many D's are on this page. The way that this would work in a MapReduce type fashion is first we go and we're always working with key value stores. So first we've got to go and take this list and turn it into a key value store. So we start out by just enumerating that. So we enumerated 0 through 4, and we have A, B, B, C, and D. Then we go and we got to perform some action on it. So now we're taking all of these values, and we know that by definition when we brought them in, each of them existed exactly one time. So now we've got our same list A, B, B, C, and D, and we've got that appended with a 1. But now that we have this information, now we can start to parallelize it. In that I can go through here and run a function and say, for every A, just put them out into a list. For every B, put them out into a list. And after that, we come through and let's just go ahead and sum across that. What we end up with is our word count. Now this is an unbelievably simple example, but let's imagine we were working with a 40 terabyte data set, right? The beauty of this is these operations are parallelizable. So as I was going through and I was enumerating all of the A's, enumerating the B's, the C's, and the D's, I could do those all in parallel. And as I was going and summing these up, I could do those all in parallel. And we'll talk about the architecture of a Hadoop cluster and how that lays out, how you lay out the data itself, and how Hadoop is designed to keep that data local and ultimately increase performance to its maximum level. So that instead of you having a job running on one node, it can be spread out across a number of different nodes, executed in parallel, and ultimately get that job done quicker. The other piece here to understand is the way that the Hadoop architecture works itself, in that there are a number of different nodes and they have different functions within the system itself. So when you write a program in MapReduce, you submit that to a job client, and then it then goes and takes that and submits it to a job tracker who is responsible for that job. That job tracker then goes and it's what's taking that mapping function, that shuffle function, that reduction function, and it's assigning it to a number of task tracker nodes. And the beauty of this is when we get into how the task tracker interacts with HDFS itself and how that allocation is made, in that it's made with an intelligence of where that data lives, so that we always minimize the amount of moving data from one node to another to make it the highest performing system possible. So what you end up with when you look from a larger perspective is we started out with our client, we submit our job to the job tracker, and it submits out to task trackers. But the second half of that is HDFS itself. And HDFS is taking all of the data that we loaded, and there's a single name node here, which is keeping track of the indices of all of that data, and it's sending out to a number of different data nodes. So now I can go and take that data, and it won't just send it to one data node, but you'll define how many you want to send it to. It's typically sent to about 3 different data nodes. You'll have that data located on 3 different data nodes. And so now this task tracker has access to these various data nodes. And when you go and the job tracker says, all right, I want you to run this job on this particular data set, it's going to assign it to a task tracker that's running on that exact data node. So now you don't need to have a massive shared file system in the back end. It's utilizing all local disk and getting the highest performance possible. So this is some of that intelligence of what Hadoop gives you to get extremely high performance levels at commodity prices, utilizing commodity hardware. And I won't go through this in a tremendous amount of detail, but when you start working with Hadoop, there are 2 key frameworks that you're going to want to utilize. The first is a language called Hive. And Hive is most closely related to SQL than any other aspect of Hadoop. So if you are very, very new to Hadoop and you are now working and trying to move into this new world and you think in SQL, well, then Hive is a good transition for you. But ultimately, when we get to thinking of things in procedural aspects, kind of like we talked about with MapReduce of, okay, first I load the data, and then I perform this transformation, and then this, and then the other, then you're going to want to start looking at Pig. And Pig is really the key behind any Hadoop solution. Pig is referred to as the duct tape of Hadoop, because you can do a number of things in the language itself, as well as embed other scripts in there that merely makes it an extremely flexible solution. So now that we've covered that theoretical components of how you would get started with Hadoop, I want to shift gears a little bit and go into some of the specific products and solutions that will help you with that. So when we start looking at NoSQL itself and what solutions are available there, and we start looking at that simple key value store, this is used more often for caching than anything else. So I'll use an example of Redis here. And once again, it's a very simple database. We don't see it used all that often in very complex environments, but it works very well for simple caches. What we start to see more often, and we've seen very, very heavy use of this with web applications, is those document databases. So if we go back to what we were talking about earlier, this is a key value store, but it's more complex now in that instead of just a simple value, I actually have a document in a JSON or an XML format. And now you get into technologies like Couchbase and MongoDB, which we see used very, very often with web applications. And what starts to make these types of NoSQL databases really, really interesting when we start talking about big data is not only do they provide you the ability to store large data sets, but they actually have some native integration with MapReduce and Hadoop that make the system a lot easier to work with as a whole. Here, as an example, let's say that you went and you launched a MongoDB database. And then you went and you said, all right, now that I've solved that initial problem of how do I take all of this data and store it in my database, what do I do with it? Well, you have some ability without going and standing up a whole Hadoop cluster to run some basic analytics on there. You can write a MapReduce job in JavaScript and actually query that database directly. MongoDB has that capability to it. So you can start to get your feet wet and start moving in that direction. And then when you do actually get to the point where you want to go and stand up that whole Hadoop cluster, there's now the inherent problem of, okay, how do I take the data that's in my MongoDB database that I'm continuing to work on an operational perspective and continuing to work with, and how do I load it into HDFS? And how do I get it into my Hadoop cluster so that I can start working with it? Now, Tengen has actually developed a connector here that allows you to go and take that data that's stored in that MongoDB database and integrate it into Hadoop so that you can get that data there and then start to perform those more advanced analytics. Take it a step further into a more complex data structure. And let's say that you actually wanted to go and build a distributed file system. So just that the document database wasn't quite what you were looking for. You're looking for something that's a really massively scalable NoSQL database solution that you can run out on the cloud. And I should say right now that databases like Cassandra are more complex. You look at technologies like MongoDB, and it's very simple and easy to get started. And when you start comparing that with a Cassandra database that's utilizing a column topology, and it's utilizing the ring replication and all of the advantages that we'll see with Cassandra that we don't have time to go through today, it does require a little bit more knowledge, and it takes some work to get started. But specifically when you start looking at Hadoop, there's some really, really cool things that you can start to utilize with Cassandra in particular. The company behind Cassandra, or DataStax, that makes a commercial distribution of Cassandra, has done some really, really cool things. When we started looking at that Mongo example, you said, all right, there was a connector for taking my data in that NoSQL database and bringing it into my Hadoop cluster. Well, DataStax has gone to the extent of actually building native integration for the Cassandra file system into Hadoop. So now I can go and I don't have to go through that additional process of loading that data. I can use, quite literally, the same nodes. And I could have my task tracker running co-located on the nodes where my Cassandra database is running. So now it's taking it to yet another level. So you could continue to operate this similar to what we had talked about earlier. And you have dedicated nodes acting as your Hadoop cluster and dedicated nodes acting as your Cassandra cluster. Or you could actually go to this extent of having them co-located. When you start having them co-located, now you have not only less infrastructure that you're managing, but now you start getting to even higher performance levels. Because now this data never needs to leave from one place to another. It stays on those same nodes, and you can interact with it on an ongoing basis through the Cassandra interface, as well as through Hadoop with the MapReduce jobs that we've been talking about. That takes us into the Hadoop element itself, right? So we've talked about what big data is and what the challenges are with big data that we're facing. We've talked a lot about NoSQL and some of the capabilities there. But then you actually get to the point where you say, all right, how do I actually get started with Hadoop running out on the cloud? The way I approach this is by working with one of our key partners, IBM in this case. And IBM has developed a set of technologies which will enable you to get started with Hadoop on the cloud very easily and effectively. And I've been through this process myself. I'll define it in 3 steps. And it's learn it, try it, and buy it. So it starts out with an unbelievable resource for anyone that's really getting started on the cloud. So most of the information in this presentation was actually screenshots from an online training course that IBM has developed called Big Data University. And it goes through these foundational components of how Hadoop works and really gives you that basic knowledge of how to get started. That's what we've heard from more and more people is they say, hey, Hadoop is great, but it's this whole other language out here. It's this whole other set of domain knowledge. And I start picking up a document and start reading it, and I don't even know what I'm reading. I don't know where to start. And that's what I thought Big Data University did such a phenomenal job of, is going and really giving you those foundational components that you need to get your feet wet. So it's out there. The best part is it's free. It's available for you to utilize. It's a series of video trainings as well as documents. And I went through it. The best part about it is it's in these tiny little 20-minute modules maybe. So you can go through it and really go through it at your own place, at your own pace, and make sure that you understand that technology. So I went through a number of these different modules, and I mean, it's intense stuff. And some of them I went through 2 or 3 times. And it really allows you and gives you that discipline to make sure that you understand it as you go through it. So I highly recommend you take a look at this. It's available for free out at bigdatauniversity.com. The next thing is, as you go through that training module, IBM has actually gone, and IBM has a couple of products here in their BigInsights family. So they have a basic edition of BigInsights, which is their Hadoop Analog. And it's effectively, they've taken Hadoop and they've hardened it and provided a support structure around that so that you can use it in an enterprise structure. And they've built that module out there, and they've built a set of server templates out here, which are available within the RightScale multi-cloud marketplace. And they are already built to work across multiple different clouds. So one of these things we're seeing with a number of different cloud providers as they're coming out is they're not all just going and launching Amazon clones. And many of them are targeting specifically storage performance. And they're starting to come out with these very, very high performance storage backends. And when you start looking at that and you start leveraging this solution, you have this whole training module and these pre-configured server templates which automate the process of building this cluster. You can go and spend a weekend learning this stuff and spend 30 minutes going and actually building that Hadoop cluster out on the cloud And the best part is it's a free solution. So they cap it at 10 terabytes, but most people that are getting started, that seems like about a reasonable level. And what's nice here is they then go and give you the ability to take that environment and step it up to the next level with the Enterprise Edition of BigInsights. So IBM just released a new version of BigInsights, and they're going to be publishing that into the multi-cloud marketplace here shortly. There's a lot of really, really cool things that they're doing there. I'll give you a couple of examples. First one that I like to use is they give you a number of different interfaces to interact with the Hadoop cluster itself. One of them is called Big Sheets. That's effectively a spreadsheet-like interface to interact with that Hadoop cluster. So it allows you to take someone who might be new to Hadoop and give them an interface that they're comfortable with, that they know how to utilize. Maybe an upper-level manager wants to start working on some of this stuff. Well, they'll know how to use spreadsheets, and they get that sort of an interface that they can work with. IBM is also developing an augmentation to Hadoop for streaming analytics. So I started out the presentation by talking about how Hadoop was really a batch processing technology. That you had to have all of this data and load it into HDFS and perform this job on it, but it didn't really have that streaming analytics capability of taking a Facebook feed or a Twitter feed and analyzing it in real time. And we've seen the same challenges with our prospects and customers that we've talked to that IBM has, and they're actually building an augmentation to Hadoop called Streams. And that's incorporated within BigInsights that when they publish these server templates here in the next week or so with their new version, it'll actually include a trial of Streams. So you can use the Hadoop that everyone's been working with for so long. You can leverage all of that capability. You have the IBM support structure behind you. You also have these more advanced interfaces that you can work with. And you start getting technologies like Streams. And of course, you have IBM backing the entire thing. And as we talked about, it's available through RightScale across a number of different clouds. So we covered a lot of different things here. We really wanted to try to give you the foundational elements of the challenges of approaching big data and some of the potential solutions that are out there. Specifically, we talked about NoSQL, we talked about Hadoop, and we talked specifically about some of the IBM technologies that are out there.